All right, today we're tackling one of the biggest questions in the tech world, SQL versus NoSQL. And look, this isn't just some nerdy technical debate. It's actually a huge deal that affects pretty much everything you do online, from checking your bank balance to scrolling through your social feed. It's all about how we organize, well, all the information on the internet.
So let's just boil it all down to one single question, right? How should we organize all the data in the world? I mean, think about it. Do you go for something like a super neat, tidy library where every single thing has its own special spot? Or do you lean into the, let's say, organized chaos of a giant, bustling flea market? How you answer that question? Well, that's the key to understanding this entire debate. All right, the library versus the flea market. This is the core analogy we're going to use. Trust me, the best way to get your head around SQL and NoSQL isn't getting lost in code. It's this simple comparison. Stick with it, and I promise it'll all make sense. Okay, so on one side, you've got SQL. That's our library. Think super organized, strict rules, everything in its proper place. Every book has a specific spot on a shelf. You mess with the order, the system gets mad. Then, on the other side, you have NoSQL. That's our flea market. It's flexible, a little wild, and totally dynamic. Each vendor can set up their stall however they want. You've got one person selling vintage clothes, the person next to them is selling handmade jewelry. It's all about freedom and flexibility. This is where it gets really interesting because we're talking about the rules of the data. In the SQL library, you have a strict schema. Think of it like the template for a library card. Before you even add the first book, you have to decide that every card will have a title, an author, and a publication date. No exceptions. Everything has to fit that mold. But in the NoSQL flea market, forget about it. There's no rigid schema. One vendor can label an item with price and color. The vendor right next door could have a similar item but label it with cost, material, and origin story. The data can change on the fly for every single item.
And here's what that looks like in the real world. Just look at the SQL table. It's a grid, right? Super rigid. Every user, Alice and Bob, they must have an ID, a name, and an email. The columns are set in stone. Now check out the NoSQL side. It's a couple of documents. Alice has her email, great. But what about Bob? Well, we don't have his email, but we do have his phone number. In NoSQL, that's no big deal at all. You just add a phone field for Bob. Done. Trying to do that in the SQL table? Oh man, that's a whole different and much more painful story.
Okay, so finding and storing data. If these things are organized so differently, how on earth do you find anything quickly? Well, this is where we get into the librarian's index versus the vendor's notebook.
So, in the SQL world, the magic behind finding stuff fast is usually something called a B tree. Don't worry too much about the name. All you need to know is that it's a super smart, self-balancing tree structure. It's just incredibly good at searching, sorting, and grabbing chunks of data with lightning speed. It's basically the gold standard for organized data lookup. And to bring that right back to our library, the B tree is basically that perfect old-school card catalog. You want to find Moby Dick? You're not going to walk down every single aisle looking at every book spine. No way. You go straight to the index for M, find the card, and it tells you exactly where to go. Aisle 7, shelf 3. Boom, you're there in seconds. It's all about precision and speed for finding one specific thing. Now, on the flip side, a lot of NoSQL databases use a totally different trick. It's often based on something called an SS table or a sorted string table. And here, the number one goal is different. It's not about finding things perfectly, it's about writing new information down as fast as you possibly can. New data just gets added to a list. Boom, boom, boom. The organizing, the sorting, that happens later. This is a perfect match for our busy flea market vendor, right? A new box of stuff arrives. Is she going to stop selling to perfectly catalog every single item? Of course not. She's just going to scribble it down in her notebook real quick to keep track of it. Then, at the end of the day, when things are quiet, she'll merge that notebook into her main inventory list. This whole system is built for one thing: speed. Insanely fast writes. Think about logging data from millions of devices at once. This is how you do it.
All right, next up, how to scale. So, your library or your flea market is a huge hit. You've got more customers and more stuff than you know what to do with. How do you handle the growth? This is what we call scaling. And you guessed it, the two philosophies are night and day. The classic SQL way is called scaling up, or vertical scaling. To make your library bigger, you basically have to, well, build a bigger, taller library. In the tech world, this means you buy one single, monstrously powerful computer, a giant server. But there's a big catch. Moving everything over can mean shutting down for a bit. And worse, if that one mega server ever goes down, the whole library is closed for business. It's a single point of failure.
NoSQL was born to do the exact opposite.
It's all about scaling out, or horizontal scaling. Instead of one giant building, you just add more stalls to the flea market. You can just keep adding a bunch of normal, off-the-shelf computers and spread the work across all of them. And the beautiful part, if one vendor's stall has a problem and closes down, who cares? The rest of the market is still open and running. It's way more flexible and way more resilient. And there's a cool name for this process of spreading your data out. It's called sharding. You're literally taking your giant pile of data, slicing it up into smaller pieces, or shards, and then you put each piece on a different computer. That right there, that's the secret sauce that makes horizontal scaling work.
But here's the real kicker. For a traditional SQL database, sharding is hard. It can be a total nightmare to set up and manage. Imagine trying to have one single perfect card catalog that works across 3 separate library buildings in different parts of town. It's a logistical mess. But for NoSQL databases, sharding is just what they do. It's built into their DNA. It's as easy as a new vendor showing up at the flea market and just claiming an open spot.
Okay, guarantees versus speed. This brings us to a really critical trade-off. What's more important to you, the rock-solid guarantees of a bank or the lightning-fast updates of a social network?
SQL databases are all about something called ACID guarantees. It stands for atomicity, consistency, isolation, and durability. But honestly, all you really need to remember is this: it's all or nothing. Think about a bank transfer. When you send money, you need the money to leave your account and arrive in the other person's account. Both things have to happen perfectly as one single operation. You can't have one without the other. That is a transaction, and that is the banker's guarantee. It's got to be perfect.
NoSQL systems often take a different route. Their model is called BASE, basically available, soft state, eventually consistent. The big idea here is that being online and available is the most important thing. It prioritizes availability over being perfectly, instantly consistent. So you like a friend's photo. Does it matter if it takes 2 seconds for that like to show up for your cousin in another country? Not really. The system will catch up. It will become eventually consistent. Speed and staying online is the name of the game.
And this chart just lays it all out, plain and simple. Look at SQL. It's all in on consistency. The data is going to be correct, period. It'll sacrifice some flexibility to make that happen. Then you look at NoSQL, and it's a different story. It's shooting for the moon on flexibility and scale, and it's willing to trade a little bit of that immediate perfect consistency to get there.
So the big question is, which one do you pick? When do you need a library? And when is a flea market the right call? Let's get practical and look at some real-world use cases.
You go with SQL, our library, when you absolutely cannot afford to make a mistake. We're talking about things like banking systems. Every penny has to be accounted for. Or managing orders for an online store. You can't accidentally sell the same laptop to 2 different people. Basically, anywhere that losing data or having an error would be a complete disaster, you need SQL. And you go with NoSQL, our flea market, when you're dealing with insane amounts of data that's coming in super fast and doesn't have a neat structure. Think about a social media feed just swallowing millions of posts and comments every second, or trying to make sense of huge, messy, big data sets, or even collecting tiny bits of information from billions of IoT sensors out in the world. For that kind of stuff, the speed and flexibility of NoSQL is exactly what you need.
Okay, let's wrap this all up in a neat little bow. SQL, you use it for structured data when consistency is everything. You scale it up with a strict schema. Your classic examples are MySQL and PostgreSQL. NoSQL, you use it for messy, unstructured data when you need massive scale and flexibility. You scale it out with a flexible schema. Think MongoDB or Cassandra. At the end of the day, it's not about which one is better. It's always about picking the right tool for the job.
And that really leaves us with a final, pretty big question, doesn't it? We're creating more data and more kinds of data than in any other time in history. So what does the future look like? Are we going to need more perfectly organized libraries or more sprawling, dynamic flea markets? Or, and this is the exciting part, is the next big thing something else entirely, something we haven't even thought up yet? Something to chew on. Thanks so much for joining me.